Ladies and gentlemen, charging infrastructure plays a key role in the uptake of electric vehicles. With electric vehicle charging, one hears about the AC charging and DC charging. But what is the difference between these two? What is the fast charging? In this lecture, we will talk about the basics of electric vehicle charging and find answers to these questions. In the electricity grid, the electric power is alternating current, or AC, by nature. However, the electric power of a battery is direct current, or DC, by nature. Hence, to charge an electric car from the AC grid, the power has to be converted from AC to DC. An electric vehicle charging system has three main parts. The first part is the AC to DC power electronic converter. As mentioned earlier, this converts the power from the AC to DC. The second part is the charging cable with a connector that is used to feed power from an external power supply to the electric car via the vehicle inlet. Finally, a charge controller on the external power supply side and the battery management system on the vehicle side are responsible for the communication, protection, and control of the charging process. They control the charging current and stop the charging in case of overcharging, complete draining, short circuit, or overvoltage of the battery. It also ensures that the temperature and balancing between the cells are optimal for long battery life. Hence, to charge an electric vehicle, AC power from the electricity grid is fed to the car via the vehicle inlet using the charging cable and connector. The onboard charger, which is an AC to DC power converter, converts the AC power to DC power suitable for charging the battery. What we have seen till now is referred to an AC charging. The size and weight of the onboard charger are dependent on the maximum charging power. Typically, onboard chargers have a maximum power in the range of 1.9 to 22 kilowatts. If the charging power has to be further increased, then the charger will become bigger and heavier. However, due to the size and weight restrictions inside the vehicle, the onboard charger is limited in size and weight as well. Therefore, the solution to increase the charging power is to move to the AC-DC converter outside of the vehicle and place it in an off-board charger. This is referred to as DC charging. With no size and weight restrictions, the off-board charger can have a maximum charging power of 50 to 350 kilowatts. In case of DC charging, the off-board charger has an AC to DC power converter, and DC power is directly fed to the car via DC charging vehicle inlet. We hence have both AC and DC charging of electric cars depending on whether the onboard or off-board charger is used. While Tesla cars use the same vehicle inlet for both AC and DC charging, all other manufacturers have separate vehicle inlet for AC and DC charging as shown in the picture. AC and DC charging are characterized by the connector type and the charging power levels that can be reached. Let us now analyze this. For AC charging, Type 1 connector is commonly used in the United States and Japan, while Type 2 and the less common Type 3 connectors are used in Europe. Tesla uses its proprietary connector in the USA and Japan, while it uses the Type 2 connector in Europe. Other parts of the world are often adopting the Type 2 connector, as it can work with both 230-volt single-phase and 400-volt three-phase connections. In terms of DC charging, the CHAdeMO Type 4 connector is used by Japanese car manufacturers globally, while the American and European car manufacturers have adopted a combined AC-DC connector called the Combined Connector Combo. Interestingly, Tesla uses the same connector meant for AC charging for DC charging as well. In the case of China, they have their own DC connector. The conclusion is that the electrical vehicle industry has not agreed on one specific connector, so depending on the car brand, country, and whether it is AC or DC charging, the connector varies in shape, size, and pin configuration. With AC and DC charging, the charging power can be split into three levels, level 1 up to level 3. Generally, level 1 refers to charging power up to 10 kW, while level 2 refers to charging power up to 50 kW. Both AC and DC charging can provide level 2 charging power. Beyond 50 kW, only DC charging using an off-board charger is used to provide charging power as high as 350 kW. Level 3 charging is often called as fast charging. If we assume that an electric vehicle can drive 5 km using 1 kWh of energy, these charging powers can be translated into kilometers of range that can be added per hour of charging. We can easily see how level 1 and level 2 charging is sufficient for daily commuting needs, and level 3 charging is useful for quick highway charging. To wrap up, electric vehicles can be charged by AC or DC charging. The main difference is that in DC charging, the AC to DC power converter is placed outside the vehicle in an off-board charger, and hence the charging power can be as high as 350 kW. In case of AC charging, the onboard charger is used, which is usually restricted to less than 22 kW. Finally, since car manufacturers have not agreed on a single connector, various connectors are used for AC and DC charging globally.